And we will then hopefully be able to take some questions if we have time at the end in the Q&A feature. Hayes Cummins will start. He is an oceanographer and marine ecologist who will discuss some of climate change's implications and what can be done to manage some of the worst impacts. Donna McCollum is a freshwater stream ecologist who will discuss how the protection of stream corridors from development increases forest habitat, protects critical wetlands, and supports biodiversity. And Jim Finch is a senior attorney with the US EPA's Water Enforcement Division, who will discuss the history of the Clean Water Act, key challenges it faced in recent years, and the promise of the Biden-Harris administration. All right, again, I'll ask panelists to stay on mute until it's your time to talk, and I'll do some transition in between. Hayes, if you'd like to get started.
Thank you, Jackie. I'm going to do the share screen. Okay. Okay, welcome to this session. Today I'm going to talk about coral reefs and climate change and coastal ecosystems in general. The bulk of the source material for today's talk is from the Intergovernmental Panel on Climate Change and the Great Barrier Reef Marine Park Authority and NOAA. Thank you, Tom. So I'm going to talk about the current climate change. All of these things will be discussed very briefly due to time constraints. But history, and I'm going to concentrate on the
Hey, Hayes, I think you're frozen a bit and slowing down.
Okay. Donna, could you turn yours off? Okay. And then I'm going to talk about the short-term future of coastal ecosystems. Just to give you, I don't know if this will play for you or not. Is it coming through, Jackie? This is an example of just some of the biological exuberance that one can experience. Okay, on reefs around the world. What if it's not coming through very well? It's a movie of some reefs from Bonaire, which is an island just off the coast of Venezuela. The biological exuberance of these reefs is absolutely phenomenal. All right, the global distribution of coral reefs is indicated by all the pink dots, and typically most of them are found today between 30 degrees north latitude and 30 degrees south latitude, but concentrated toward the equatorial regions of our planet. Coral reefs have been, at least modern day genera and species, have been in the fossil record for over 150 million years, and perhaps go back as long as 200 million years. So they've been here a long time, and they've seen lots of changes and lots of ups and downs in their own environmental conditions. If we look at our carbon dioxide record, which is a very important driver of our climate here on Earth, you can see we have the concentration on the y-axis and time on the x-axis. And over the last 800,000 years or so, CO2 concentrations have gone up and down, but have stayed basically below 300 parts per million. Until the current time, where the large arrow is pointing at the dramatic increase. And I went to the most recent data yesterday, and the reading, I think, was at 415 parts per million. So I put on here ground control to Major Tom, planet Earth, we've got a problem. If you look at the CO2 concentrations from 1960 to the current, we're approaching 420 parts per million. When I was born back in 1950, I think it was about 280 or so parts per million. My wife's telling me to stop moving, so I'm going to try not to move. So why do I mean, every living species dies. Why do corals die? Well, disease, old age, stress. There's natural causes, there's human-induced causes. And let's look at stress, because with climate change, our coral reef ecosystems around the Earth, these shallow water systems, are experiencing lots of stress. For temperature, it's either too hot or too cold. With climate change, we're looking at too hot. Salinity, increasing salinity, too salty, too fresh. Turbidity, due to algae, nutrients, ocean circulation, change in currents and winds. Sediment loads due to land use changes and climate changes. Stress coral reefs, water chemistry, pH. As increased CO2 in the atmosphere, the acidity of our oceans is increasing, which is bad news for any organisms that make their own skeletons, such as corals and many other organisms. UV radiation, pollution, these are all stressors for corals. This is a pretty healthy looking reef. This is from the Great Barrier Reef. Now, I want to stress that these systems, since they have been on planet Earth for a long time, this graph shows it's a blow up over the last 500,000 years. And using oxygen isotopes, we can surmise when it was cold and when it was hot. And the peaks, the red peaks represent interglacial warm periods, and the valleys represent ice ages. And so over the last 500,000 years, we've had at least 3 different interglacial periods. And our last ice age, our last ice advance ended about 20,000 years ago. And since that time, it's been warming. The point I want to make, again, to reinforce this, is that these reef systems have endured all sorts of catastrophes from their perspective. The most recent ice age advance, since it's thought that sea level was at least 300 feet lower than it is today. That's a tremendously, but it have taken place over a pretty long time, over thousands of years, the ups and downs. We were a chance to adjust to these changes. All right, so now I'm going to move to the Great Barrier Reef. I've spent the last decade or so teaching a course on marine conservation on the Great Barrier Reef, and we have a partnership with the Great Barrier Reef Marine Park Authority. And the map on the right shows the extent of this park system. And I believe it was founded in the 70s, and there's been a world-class, outstanding effort toward understanding the function of the reef, how to protect the reef, how to involve everyone in the use of the reef. That includes protection and also the economic development of the people that live along the coastline. So it's been a partnership to protect the reef over time. So they're very proactive. They look at agricultural and farming interests along the coast, because what farmers do along the coast impacts the rivers, when the rivers impact the reef eventually. Sewage treatment, tourism, fishing regulations, management plans, education. They have an education program that it starts in kindergarten, where people kids learn to protect the environment, both terrestrial environment and reef systems. So just to put the Great Barrier Reef Marine Park into perspective, it's located primarily in Queensland, along the east coast of Australia. It's about 2,300 kilometers long. It's got over 3,000 coral reefs, 600 different types of soft and hard corals. It's roughly the same area as Italy, Japan, Germany. Only about 6% of the Great Barrier Reef Marine Park is actually coral reefs. The rest is other coastal ecosystems. But it's one of the largest marine protected areas on the Earth. And it's much more than just coral reefs. Coastal ecosystems include mangroves, coral keys, continental islands, seagrass beds, which are very important for turtle populations, shallow and deep, algal and sponge gardens, sandy and muddy bottom communities, deep ocean troughs. So in other words, this park, coral reefs are like the keystone species, like the charismatic megafauna of the Great Barrier Reef. But the community is far broader than just the corals. Coral reef systems are one of the most biologically diverse ecosystems on Earth, and this includes the amazing tropical rainforest near our equatorial regions. The species diversity is unparalleled. Over 1,600 species of fish, over 450 species of hard corals. I teach marine ecology, and in the Caribbean, typically, if you learn about 20 or so hard coral species, you've got over 95% of all of them learned. On the Great Barrier Reef, you're talking over 450 species, and so on and so forth. So one thing that the Great Barrier Reef Marine Park Authority has done is zone the reef. And what I mean by that is they've classified different sections as where the public can scuba, snorkel, fish, how many hooks on a fishing line, how many fishing poles you can have in a boat, whether or not the commercial fishermen can actually even go to an area, whether you can anchor a boat in one area or another. And the pink zones, which you see on the left, those areas are totally off limits. Even scientists, in order to go there and do research, there's a very rigorous permitting system that takes place. So they've worked really hard at demarcating the Great Barrier Reef region into zones of use. And here's an example. If you get a map of the Great Barrier Reef, you get a map with all these different colors on it. And the colors represent different zones, and the different zones have different uses. And their goal, again, is to increase resiliency for what's coming in the future, to protect the reef as best as possible for the future. Now, with all these uses, all these people doing multi-use of the Great Barrier Reef, the biggest threat by far is climate change. And it's not just corals that are impacted. Just about every species in the system is being impacted by climate change. Increased seawater temperature, increased sea level, increased weather variability, and the ocean acidification. It's a serious, serious problem. So by 2100, which is only 80 years from now, the surface temperature is predicted to increase from 1 to 3 degrees C, which results in coral bleaching, coral death, lower fish reproduction, sea turtle and dugong ranges altered, and turtle breeding patterns are altered. It's also with climate change, increased severity of storms, cyclones, and severe weather events. Flood plumes, where we go in Townsville in Queensland, it's almost a semi-desert on the continental side. But when it rains, it really, really rains. And there's lots of runoff, freshwater runoff, and agricultural runoff that goes onto the reef. So more rain, more floods, more sediment. Beach erosion and physical damage from storms. This map is from 2005 to 2019. In each of those little paths, there's 11 cyclones there that happened, and they were either category 3, 4, or 5. And this is just over the last basically 14 to 15 years. And so these storms have always happened, but the thought is that the predictions are that we'll have increased storm frequency and increased intensity. And so far, over this recent record, almost the entire Great Barrier Reef has been impacted by these very severe storms. And you couple this with increasing sea temperatures, increasing coral reef diseases, et cetera, and the reefs are under serious stress. So coral bleaching, when the water gets too warm, And then the corals and their symbiotic algae don't like it. And what happens is the coral, either the algae leave the coral or the coral expels the symbiotic algae. The algae are very important to coral and the reef building process. And when you over a reef and you look at all the colors are from the algae that are living inside of the coral. And the coral expels these algae, and then they become bleached. The coral look white, and it leaves the coral very vulnerable, and many times the coral will die. And this recent survey, all those little red dots in northern Great Barrier Reef, central and southern, show where bleaching was just off the charts, where you had magnitudes up to 10 or 15 times less living coral present after a recent coral bleaching event. And the fear is that with increased ocean temperatures, that we're going to have more and more bleaching events, which is very detrimental to these reefs. Here's a picture on the top picture is what the reef looked like in 2016 at one particular sampling spot. And then there you go in 2017. It's like the difference between night and day. Also, this is a crown or thorn starfish. This is a native predator, but what's happening with our current climate situation, no one really knows exactly why, but these crown of thorn starfish outbreaks are becoming more frequent. And on even one reef, you can have tens of thousands of these things. They're about the size of a garbage can lid, and they literally eat coral, and they can devastate a reef. So
Hayes,
the long-term
sorry, Hayes, we'll have to wrap up in about 30 seconds.
30 seconds. Okay, long-term Great Barrier Reef outlook. If you look at this graph real quickly, the temperature's on the bottom. If we get above 1.5 degrees C, the coral reefs are going to be devastated. Sea level changes. I wanted to just say the future and environmental catastrophe, increased ocean temperatures and decrease in reef diversity, rising sea levels impacting literally hundreds of millions of people. And I guess in terms of many multiple human generations, or perhaps centuries, the impacts will be severe and there'll be unexpected surprises. This is not a good situation. It's going to be very difficult to change this trajectory. Thank you very much. Hope I didn't take too much time.
You had a big subject, Hayes. No problem. Thank you.
Yeah, okay, thank you.